those are the multiples. I'll leave question 1. Okay, how about question 2?
Amelia says that 36,000 is a multiple of 3 and is also a multiple of 6. Is she right? Explain how you know. Well, I think it is, because 36 is in the 3 times table.
Mm-hmm.
I think it's wait. And it's also in the 6 times table as well.
Mm-hmm.
So,
And 6 times table.
yeah.
And so 36,000 is a multiple of both.
Yes.
So I think that's fine. Another way to do it is to do 36,000 divided by 3, and then 36,000 divided by 6. And if you get a whole number for both of them, then they're both in the in that times table. So this one is 12 and then 3 zeros, and this one is 6 and then 3 zeros. And so because they both give you whole numbers and they're both multiples. How about question 3?
Avnisha is preparing for a party. She has 240 paper cups that she wants to stack in sets of 12. Will all the sets have exactly 12 cups? So she has 240 paper cups and she wants to stack them in sets of 12. I think all the sets will have 12 cups, because 24 is in the 12 times table.
Mm-hmm. And how many sets would it be?
I think 20?
Mm-hmm. 24 divided by 12 is 20 sets. And so it would be 20 sets exactly.
Okay.
So that one is right, yeah. Excuse me. Let's do the second one.
Okay. Start with the multiples. So, multiples of 7. Well, for starters, 490 would be one of them, because 49 is in the 7 times table, and if you were to divide it by 7, you would get 70, I think.
Correct.
And 70 is in the 7 times table, so that's one of them.
Mm-hmm.
6 is obviously not one of them, because that's not in the... 19 also is not one. I don't think 32 is either.
No, 35 is.
Yeah, and 63. I think 63 is.
Mm-hmm. Yeah, 7 times 9. Let's try the last one.
What equals 6? Well, for starters, 366 is. Because if you were to... The first two numbers are 3 and a 6, which is 36, and 36 is in the 6 times table.
Mm-hmm.
And
So dividing it by 6 gives you a whole number, so it's the 61st number in the 6 times table.
yeah. $38 isn't, because that's not in the 6 times table.
Mm-hmm.
35 isn't either.
Yeah, and did you say 38, was it?
Yeah, 38 is not in the 6 times table.
Mm-hmm. And so if 38 isn't, what do you know about 380?
Not in it either.
Mm-hmm.
And so that leaves us with 354. Well, 35 isn't in the 6 times table, but the units on versus 0 are not a 4. And there are... I think it is in the 6 times table.
I think it is. So 6 into 35 goes 5 times remainder 5.
Yeah,
How many 6s in 54?
54.
Or 6 times what makes 54?
9.
Yeah.
Okay.
And so it goes exactly 59 times. So it's in the times table. Okay. Any questions there?
I don't think so.
Okay. Tricky stuff. Maybe leave that one. Okay. Let's do the last two.
So like 2 common multiples of each set of numbers. So C, it says 9 and 3. So, well, they're both in the 3 times table.
Mm-hmm.
And they're also both in the 1 times table.
So can you think of one common multiple?
Well, they're both in the 3 times table.
So 9 isn't.
Wait, 3.
Sorry. Yeah. Okay. So what's the common multiple?
3. 1, because they're also both in the 1 times table.
So that would be a factor.
Or 1.
Like 3 isn't in the 9 times table.
Oh yeah, they're not. Oh yeah, they're both. Oh yeah, they're not.
But 9 is in the 3 times table.
Yeah.
So what could you do there? So what are, let's say, the first 6 multiples of the... oh, we did it earlier, actually. The 3 times table. You said it was 3, 6, 9, 12, 15, 18.
Okay.
How about the 9 times table?
It's 9, 18, 27.
And can you find any common multiples?
Yeah, there's 1, and that's 18.
I think there's one more.
Oh yeah, 9.
Yeah. Okay. How about... and so... one way you can find a common multiple is to multiply the two together. So 3 times 9 is 27, and that's also in the 3 times table. And then you can just keep doubling that number. So what would be a common multiple for 7 and 5?
7 and 5. Well, we can do what we did just now with the two numbers. Find if there are any common multiples. So.
Or what you can do is just multiply them together.
Oh yeah. 7 times 5. That is 35.
Yeah. So 35 is the 5th number in the 7 times table and the 7th number in the 5th times table.
Yeah.
And so how can you get a second multiple? Common multiple of 7 and 5.
Oh, actually, no.
So you can just double the common multiple, and that'll be another common multiple.
Oh, okay. So 35 plus 35, that's 70.
Yeah, and that will keep working. And you could get smaller numbers, but that is one way to get common multiples.
Okay.
And that works for the 9 and 3 as well. So you could do 27 and then double 27. Okay, let's try this one.
Really is setting out chairs in the straw hall. She has 450 chairs and sets out 30 chairs in each row. How many rows of chairs will there be? We can, I think, divide 30 from 450.
Yeah. So I'm going to write it as a fraction. See if that's easier. How would you do that?
I don't know actually do this at school.
Is there any number you can divide the top and bottom by?
Well, you can divide 0 and 0 because that's 0.
So you can they end in a 0, so you can divide the top and bottom by 10.
Top number, divide it.
So what would you get if you divided the top and bottom by 10?
What, 0 divided by 10? Or the other way around?
Oh no, 450 divided by 10.
Oh, that's 45.0.
Yeah, and the bottom number?
That is 3.0.
Yeah, and so it's called cancelling down. You can just cross out 1 0 each.
Okay.
And that's a quick way of dividing the top and bottom by 10. So 45 over 3, or 45 divided by 3.
That equals
You can do it bit by bit. So how many 3's in 45? How many 3's in 4?
1.
Remainder.
Remainder 1.
Okay, and what's next?
3 goes into 15 5 times.
Mm-hmm. And so what is the answer for our question?
15.
15, yeah. So it's basically 450 divided by 30.
Okay, yeah.
And you can make that, the quick way would be to cross out the 2 zeros, which is the
Okay.
same as divide top and bottom by 10. Okay, how do we do this?
Eddie says 1,145,360 is a multiple of 5 and a multiple of 2. Is she right? Explain how you know. Well, it's obviously a multiple of 5 because all of the numbers in the 5 times end in either a 0 or a 5.
Uh-huh.
So it's in the 5 times table.
Yeah.
The 2, I think it's also in the 2 times table because any number in the 2 times table ends in a 0, a 2, a 4, a 6, or an 8.
Mm-hmm. Yes. And can you give me a common multiple of 5 and 2?
Common multiple. Well, 20 and one of them's 20 and the other is
Well, the simplest one would be 5 times 2.
5 times 10.
No, 5 times 2.
5 times 2. That's 10.
Yeah, and can this one be divided by 10? Evenly?
Yeah.
Yeah, how would you divide it by 10? It's the easy way.
You would just
How did we divide the top and bottom of this fraction by 10? Quick way.
just drop rid of the 0.
Yep. And so this one?
Well, 1,345,360 divided by 10 is 1,345,036.
Yes, so basically just take off the 0.
Yeah.
Yeah, and so it's definitely a common factor because it's a multiple of 10. And 5 times 2 is 10. Yeah.
Yeah, okay.
Okay, that's our answer there. So what would you give yourself for multiples? X, a half, or tick?
Maybe a half or halfway between a half or a tick.
Okay, and you can see that your answer is fine. It ends in a 0, so it's a multiple of 5, and it's even, so it's a multiple of 2. Factors. So factors are the kind of the opposite. So numbers that are the times table numbers of that one. So the factors of 24 are 1 and 24. So two numbers that multiply to make 24. So any other numbers?
2 and 24.
So they have to multiply to make 24.
Oh. Oh right. Oh yeah. Right.
So 2 and
2 and 12.
2 and 12. Yeah, another 2.
3 and 8.
Yeah.
4 and wait. 4 and 6.
4 and 6.
You can't do 5 because it's not in the 5 times table.
Mm-hmm.
6. 6 and 3.
That would make 18.
No, 6 and 4. Does that?
Yeah, and so now we've kind of gone back around, and so we stop there. Yeah, So the factors of 24 are 1, 24, 2, 12, 3, 8, 4, and 6. And
Okay.
those are the numbers that multiply to make 24. So these are the factors of 45. These are the factors of 54. What are the common factors?
The common factors. Well, the common factors of 5 are 1 and 5.
So just the common factors for both.
Both.
3, yeah.
9.
Yeah.
Can't see any others.
Yeah, that's it. So put a circle around the factors of 64.
Okay. I think maybe 6 and 16.
So 6 times what makes 64?
6 times 6 and 6 and I think 16 as well.
Like 6 times what makes 64? Like
Oh.
will 6 divide evenly into it?
Well, 64 divided by 6 is 6.
So how many 6s in 60?
In 60, that's 10.
And can you get another 6 in?
No.
And so that means it doesn't go in evenly, so it's not in the 6 times table. So that's not a factor.
I think it might be in the 12 times table.
No. 12 times 5 is 60.
Sorry. It's not 12 either. I think 32 is one of the factors.
32 times what makes 64?
2, I think.
Yeah, so that means that's 1.
Yeah, that's 1. I think 34 isn't.
Yeah.
So that's not 1. And then we just have 2 numbers left, 36 and 16. I don't think 64 is in 36 times table.
Uh-huh.
And 16, I think 16 is a factor.
Yeah, because that's similar to the 8. 8 times 2. So 6 of 8, so it'll be times 4.
Okay.
Yes. Okay, let's do C and D.
So are these statements truthful? 3 says 3 and 7 are factors of 21. Well, 3 times 7 is 21.
Yeah.
And you can, and 21 doubled, that's not 21.
So factors means numbers that will divide evenly into it.
So 3 times 7 is 21. 21 divided by 3 is 8.
No.
Wait, no, wait. Wait.
So, and they tell you this up here. 7 times 3 is 21. And so 21 divided by 3?
That's 7.
Yeah.
Yeah.
How about 21 divided by 7?
3.
Yeah. And so what does that tell you about 3 and 7? Are they factors of 21?
Yes.
Yes. So that one is true. And how about D?
7 is a factor. Well, 7 times that's 21. 21 does go equally into both numbers.
For part D?
Part D. Wait.
So 7 is a factor of 3, means that 7 divides evenly into 3.
Well, it doesn't.
Yeah, so then that one's false.
Yeah. Oh.
Yeah, that's it. Okay. List all the factors of each number. Let's just do C and D.
So for D, 13. And that 13 is.
So what times what makes 13?
13. Well, 1 times 13 for start.
Yeah, anything else?
No, I don't.
No, because it's a prime number, so it's only got itself and 1.
Okay.
And 72.
72. Well, there's 1 and 72, and there's also 2 and 72. Oh no, not 2. No, not 2. 2 is one of them.
2 times what makes 72? What is 72 divided by 2?
I think it's 36.
Yeah, so 36. 2 and 36 are factors.
I think 9 and wait.
So when you're doing this, the way I would do it is do them in order. So 72, it's 1 times 72. It's 2 times 36. So the next thing I would try is 3 times something.
So 3 times. Well.
To make 36? Sorry, to make 72?
Yeah.
And try dividing it by 3.
Okay. 20. I think maybe 24.
Yeah, 24.
So
So,
that's
24.
and maybe next is 4 times something, maybe.
Yeah, might be.
Yeah, might be. We don't know yet, but it might be. So. Wait. I think 18.
Yeah, 18.
So yeah. 5 isn't one of them because the 72 does not end in 0 or 5.
Yeah.
So we skip 5 and move on by 6. 12. I think 6 times 12 is 72.
That sounds good.
And 7. Well, we don't know, but it might be. No, I don't. Wait, no, it can't be in the 7 times 2 because 7 times 10 is 70.
That's right.
So we skip 7 and move on to 8, and then. I think 8 times 9 is 72.
Yeah, 8, 9.
9, well, and then 9 times 8, it's the same thing.
And so it now loops around, and so that's where you stop. Yeah, so well done. So 72, a very tricky one. 13, an easier one, because it's just 1 and 13.
Yeah.
72, lots of factors, and that's how you do it. Do it as a system. So 1, 2, 3, 4, going down like that. Okay. Let's see. Okay, let's do factors of 48.
So put these numbers into the right place in the table. Some of the numbers may not go in either column. Some may become in factors and go in both. Well, one's a common factor, because it goes into 42 and 48, so that goes nowhere.
Hang on, it says some of the numbers may go in, some may go in both, so one goes in both.
Yeah, one goes in both. 12 goes in 48, because 4 times 12 is 48. It doesn't go in 42, no.
Okay.
1, 12, 4 does. 4 times 12 is 48.
So that's 40. Sorry, 4.
And 2 is a common factor because it goes in both 42 and 48.
Mm-hmm.
3 doesn't go in either, I don't think, so.
I think so. So try dividing them by 3.
Okay. I'll try 48 first.
Okay.
Um, 48 divided by 3. I think it's 16.
Yeah.
So 3 goes in. Well, 3 goes in 48. And yeah. 16 does as well. That's 3 times 16 is 48.
Hmm.
8 and yeah, I think 8 and 6 both go in 48 as well.
Okay, so 8 and 6. Will either of them go in
42.
42?
6 can go. 6 times 7 is 42.
Okay.
So 6 goes in both. 8, yeah, 8. I don't think.
No,
No, 8 can't. 8 can't go in 42.
because 8 times 5 is 40, so it's
Yeah.
close.
So, 42. That does not go in 48, but it does go in 42 because that's the same number, and it's in its first times table. What all numbers are.
Yeah, so how about this one?
48. That goes in 48 as well. That goes in 48 because it's the same number.
Mm-hmm.
Uh,
And maybe we'll finish that later. I think it's okay there. Okay, how about this?
Amelia and Emily have 56 buns on a cake stall. They want to arrange them in rows. What possible arrangements could they use? Find pairs of factors so you don't miss any. So they have 56 buns, and they want to arrange them in rows. They could, well, they could arrange them in rows of 2. Well, they have the space to.
So 2 by what?
2 times. Well, 56 divided by 2 is wait. I think it's 20. 28, I think.
Yeah. Okay.
And then I can also arrange them in rows of 28, because that's basically the same thing.
Mm-hmm.
They can also arrange them in rows of, I think, 7 and 8.
So try following the way we did it before. So start with 1.
Oh yeah. So 1 times, so they can do it in rows of 1 if they have the space. So 1 times, so 1 and 56.
Yeah. Then 2 by 28.
3. 3. Well, if it does, I think maybe 3 and. 18.
So how many 3 is in 5?
That's 1. That's 1 3.
Remainder?
2.
3 is in 26.
That is 7.
Three.
Wait, no. Wait, no, not. Wait.
So 3 times 10 is 30. So what do you think of this one?
So, well, yeah, so. Well, 8. What, 8 threes?
Yeah. And is there a remainder?
2.
Yeah. And so because there's a remainder, then 3 isn't in the times table. 3 isn't a factor of 56.
Yeah, okay. So, no. 4, well, possibly 4 and. Wait. Maybe.
Yeah.
And then 5, well, not 5 because it doesn't end in 0 or 5, so not 5. 6.
Uh-huh.
6. I don't think 6 either, because 6 times 10 is 60.
Yeah.
No. And then 7. So we skip 5 and 6. And move on to 7, which is 7 and 8.
Yeah.
And then I think we. Wait. And then 8 by 7, that's the same thing.
Yeah, and so then we stop there. Okay, that's our answer. Any questions with that?
I don't think so.
Okay. Let's try. I think we're okay for there. How about question 5?
Arthur says that 6 and 7 are both factors of 8 and 442. Is he? How do you know? Well, 6 times 7.
Mm-hmm.
That equals. That equals 2.
Yeah.
And then double that.
So you can just go straight away, see if that goes into 8442.
So 2 goes into 8.
42. How many times is it going to 84?
Wait, oh yeah, 42. It goes into 84 2 times, I think.
Yeah.
So that's 2. No remainders for now. And 42 and 42, well that's 1, because 42 times 1 is 42.
Mm-hmm. And so, is he correct?
Yes.
Yes. Yes, because 42 is a common multiple. And 42 divides evenly into 8, 4, 4, 2, 21 times.
Okay.
So just it divides in evenly is the main thing. Okay, any questions there?
I don't think so.
Okay. So that is factors x a half or tick.
I think maybe either like before, halfway between a half or tick or tick.
Okay, let's put it there for now. We see how we get on.
Okay.
So we'll go back to our little test. So multiples are numbers that are in that times table.
Yeah, like three, like it says, 3 times 4 is 12.
Yeah. So put a circle around all the multiples of 8 on the top line.
8. So 8. Well, I think 64 is one of them because 8 times 6 is 64. I think. Yeah.
Mm-hmm.
Yeah, that's correct. 60 and 62. That's not in the 8 times table. So that's not 1. 67. That's not in it either. And 72 and 76. I think 72 is 1, because 8 times 7.
Yeah.
And 76 isn't 1, because that's near 72.
That's it. So part A, circle the multiples of 4.
Well, 8 is 1, because 4 times 2 is 8. 24 is 1, because, yeah, just 4 times 6 is 24.
That's okay. How about C, the multiples of 9?
99 is 1, because 9 times 7 is 99.
Mm-hmm.
18 is also 1, it's 9 times 2. 27 is also 1, because 9 times 3 is 27. 180. I think that's not 1. No, actually, wait. Yeah, wait, it is.
Yeah, so if it's 9 times 2 for 18, then it's 9 times 20 for 180.
Oh yeah. And 72, I think that is 1.
Yeah.
9 times 8 is 72.
Yeah, so they all are. Okay, how about this?
Put the numbers into the right place in the table. So even number, odd number, multiple of 7, not a multiple of 7. So 2 have also been done. So 14, that's an even number. And it is a multiple of 7, because 7 times 2 is 14.
Uh-huh.
So that would go into the multiple 7 and even number box.
Yeah, so top left.
49, that's a multiple of 7, because 7 times 7 is 49. And so that would go in the odd number multiple 7 box.
Odd number multiple of 7, so that's bottom left, yeah. Can you find one that will go in the other two that we haven't done?
Okay, 15 for a start, because 7 times 2 is 14, and that's the closest we can get. So, it would go in the odd number, not a multiple 7 box.
Yeah.
For an even number, that's not a multiple 7, that's on there.
And is there an even number that's not a multiple of 7?
I don't think 26 is. Wait. 7, 14. Wait, it is.
It is what?
Yeah, it is 1. So that would go in where 14 is.
What is the 7 times table?
Well, 7. Well, up to like the first 5, or up to
Sure, up to 35.
first 5. So 7, 14, 21, and 28.
So is 26 a multiple of 7?
No.
No.
Wait, no, I got confused then. No.
And so, which one does that go in?
It goes in the even number not a multiple of 7 box.
Yeah, so there, we've put 1 in each. I think that's okay. Okay, how about part A?
Part A. So like 2 to 1 multiples of each set of numbers. So 3 and 4. Well, 3 times 4 is 12.
Mm-hmm.
And 12 doubled, but 12 doubled is 24.
Yeah, so those two will work. Okay. We did this one, we did this. So that's multiples.
Yeah.
The factors are the numbers that you multiply together to get multiples.
Yeah.
So let's try A. Is 21 a factor of 21 is a factor of 7? True or false?
I think it's true because 21 is in 7 times table.
So that would mean 21 is a multiple of 7.
Wait.
So do you do 21 times something to get 7?
No.
No, so that one's false.
Yeah.
How about B?
The 7. Well, 7 is a multiple of 21. I think true. Wait. Multiple. Wait, no. Wait, times always multiple. I think true.
7 is a factor of 21 because it's one of the numbers you multiply.
Oh, yeah.
So 7 isn't in the 21 times table. It would be the other way around. And so that one is false. So 21 is a multiple of 7, or 7 is a factor of 21.
Oh, okay.
That's how that works.
Oh, I think I get it now.
Okay, let's do part B. What are the multiples of 15? Sorry, the factors of 15.
Well, 1 and 15.
Yeah.
2's not one of them because 15 is not an even number. 3 and 5. 4 is not one either. Wait, 4, 8, 12. Yeah, there's the closest we can get is 4 times 3. So sit that. 5 is 5 times 3, which we've already done.
Yeah, and so it goes back around.
Yeah, so that's it.
That's it. Well done. This one, I think we're okay there. We did that. Okay, so question 4. Let's try this.
Are these statements true or false? 18 is a factor of 3. I think. I think true.
False. 18 is a multiple
Oh yeah.
of 3.
Oh yeah. So multiple. So for B, 3 is a factor of 18. That's true.
So that is true.
Yeah, that's true. 18 is a factor of 6. true, I think.
So why wasn't 18 a factor of 3?
Because there's 18's not in the 3 times table.
Well, it is in the 3 times table because it's a multiple of 3. A factor is always smaller, a multiple is always bigger.
Okay. Well, because if it well, if it was 3 is a multiple of 18, that would be true. Wait. It was false because
So a factor is always smaller.
yeah, it's always smaller.
So 18 can't be a factor of 3.
Well, it can't be because factors are smaller and 18 is larger than 3.
Okay, so part C.
Okay. So, well, that's. I don't think that's. Well, that's. I think that's false.
Yeah.
Yeah, false.
For it to be a factor, it'd have to be smaller and have to go in evenly. And yeah, 18 is a multiple of 6, it's not a factor. Okay, so, and that's that. So next would be prime numbers and all that. So that was multiples and factors. How did you find that, Richard?
I think tick or halfway between a half and tick.
Yeah, tricky stuff, but good. So next, what is in the book is like prime numbers, because we started with some primes. Do you want to do that next or something else?